The peach is the main fruit tree in the Southeastern United States, with about 20% of the total peach-bearing acreage in the United States located in South Carolina. Peach trees are often fertilized following standard calendar-based fertilization plans without considering tree requirements of specific orchards. Nutritional deficiencies reduce tree growth, productivity, and fruit size and quality. However, in commercial peach tree orchards in the Southeastern U.S., deficiencies are not as common as over-fertilization, specifically excessive nitrogen and potassium. When nutrients are applied in excess, luxuriant vegetative growth causes internal canopy shading and reduces fruit quality for the current year and flower bud production for next year's crop. Increased growth during the summer also creates extra labor costs for pruning in the dormant season. This dense canopy can reduce air movement inside the canopy and impede penetration of foliarly applied pesticides. As a result, conditions that favor the growth of fungal diseases may be created. Also, excessive fertilizer applications may increase leaching and runoff of nutrients and cause soil and underground water pollution. Furthermore, decades of high-input production systems with a sole focus on productivity has led to depleted soils with low organic matter, low microbial activity, reduced capacity to recycle nutrients, poor water infiltration, and increased erosion. Under these conditions, tree health is compromised as trees become more susceptible to stresses and require more labor and inputs such as increased pesticide applications, and long-term sustainability of orchards is reduced. In this context, the adoption of orchard management practices to maintain soil health and fertility should consider a holistic approach comprising the soil, the trees, and the characteristics of the orchard, including varieties, age, previous year crop, climate, and current environmental conditions. The objectives of this project are 1. To identify best management practices for optimizing fertilization in peach tree orchards and reduce cost while reducing environmental problems derived from excess of chemicals in soil and groundwater. And 2. To assess the effect of adding soil organic carbon for improving soil nutrient recycling and water holding capacity, tree water and nutritional status, tree growth, and yield. In our studies on optimization of nutritional programs, we're estimating the annual nutrient requirements of orchards based on a balanced approach. By calculating the amount of nutrients removed annually, we estimate the nutrients that need to be replenished. For this approach, a rational fertilization program needs to consider the effects of tree age and growth rate, ripening time, intensity of pruning and thinning, previous year crop, soil, and environmental events that affect nutrient uptake and storage in the reserves. In regard to soil health, we are conducting field studies to measure how the incorporation of soil organic carbon prior to tree planting, followed by surface application annually, can improve soil characteristics, tree nutritional status, water use efficiency, and productivity. Sources include local food waste and poultry litter compost and mulch. The outcome will be new guidelines with updated fertilization management practices for peach growers in the region, as well as practices directed to improving soil health. We expect these will have an impact on the long-term sustainability and profitability of stone fruit orchards. This research supports the public service activities of Clemson University through its cooperative extension service, as our results are often shared with farmers and stakeholders of South Carolina. These results will allow the peach industry to become more efficient in the use of inputs and reduce costs while protecting our natural resources, thus contributing to increasing long-term profitability and sustainability of our farms.